So we know for different levels of diversification, different values of correlation coefficient, I get a different risky asset allocation set. And given a set, I can choose where I need to be on this line to choose the maximum sloped cal. Let's move on, and we're just going to think about the blue line now. We're just going to go back to assuming that the correlation coefficient is 30%. And so back to correlation coefficient of 30%. So our P star is the 60-40 portfolio with expected return of P at 11 and sigma P star at 14.20. And so I'm at the 60-40 portfolio, 60% of my money in asset 1 and 40% in asset 2. And I have a slope of 42%. So let's assume that this is our investment universe. The theory says that given this investment universe, which is the 1320 asset 1 risky asset and the 812 asset 2 risky asset, the two of these assets having a correlation coefficient of 30% and a risk-free rate, a risk-free asset of 5%, then given that this opportunity set is what exists, everybody is going to choose to be in the 60-40 portfolio P star. Everybody's going to choose it because it provides the best risk-return trade-off, it has the steepest sloped cal, and it has the maximum Sharpe ratio. Now, we'll talk about how important this assumption is later, but for now, this is the assumption that everybody's going to choose this portfolio because it's optimal, and everybody's going to act rationally, and everybody's going to try to maximize the risk-return trade-off. And remember, we measure the risk-return trade-off by the Sharpe ratio or the slope of the capital allocation line, this 0.42. So now that we've chosen this 60-40 portfolio P, we need to figure out where we're going to be on this line. Where do we want to be on this line? And remember that technically to the right of this line should be kinked because I would be borrowing and not lending, and so I would have a steeper slope to the right of P star, but let's ignore that for now and just figure out where we want to be on this optimal cal. Well, we know how to do this from the last chapter. We want to choose the optimal combined portfolio C star that maximizes the utility for an individual investor. And so we're going to select Y star as a function of this risk aversion level. And recall that each investor will have a different risk aversion level. And so Y star, the optimal allocation of the risky portfolio in the combined portfolio C, we calculate using this equation. So given some risk aversion rate, and we're just going to choose 4.25%, sorry, not percent, I apologize, 4.25. We plug in 4.25, we plug in the statistics for P, which we know are here, 11% and 14.2. So we plug in the 11% and the 14.2 and that should be 5% risk-free. And we get 0.70 for Y star. So how do we interpret this? Well, the optimal combined portfolio has 70% of wealth in P star, which is the 60-40 risky, and 30% of wealth in the risk-free. And remember that 60-40 defines the asset 1, asset 2 60-40 allocation that is P star. 70-30 defines C star and is 70% of P star, which again is the 60-40, and 30% of the risk-free. And we can now calculate the risk and return for this optimal combined portfolio using the equations from the last chapter. And I can see that I end up with a 9.2% expected return of the optimal combined portfolio and 9.94% standard deviation risk of the optimal combined portfolio using these equations from the last chapter. And so what we've done is we have figured out asset allocation weights. Given this investment universe, we should have 70% times 60% or 42% in asset 1, 70% times 40% or 28% in asset 2, and 30% in the risk-free. This will produce, a combination of these three assets will produce a portfolio that has a return of 9.20% and a risk of 9.94%. And this is the optimal portfolio because it's going to maximize utility. I would love to be up and to the left of this, but I can't. There are other things that are achievable that would be down and to the right. I could be on a cal over here, and so I could have something here, but that's not as good. This is the best thing I can do. There's nothing that's going to be further to the left or further up on this graph that is achievable. This is the highest utility achievable portfolio given my investment universe of asset 1, asset 2, and asset 3. And that's the whole point of this Markowitz process, is that given these 3 assets, I can actually find this 9.2 return, 9.94 risk portfolio, and I would never have been able to find it without this Markowitz process. This is also sometimes called the separation process, where I separate finding P star and then finding C star. Remember, P star is the optimal risky and C star is the optimal combined. And the whole point is that I could never find this portfolio without going through this process. And there is nothing else that is available in any combination of these 3 assets that's better than this for this particular investor, defined by this A risk aversion level of 4.25 and this investment universe that's defined by these 3 assets. Asset 1, asset 2, and the risk free. And we can show that this portfolio actually also has a utility level of 0.710. We've designed our utility function so that the 7.10 is also the indifferent risk-free rate, also called the certainty equivalent rate of 7.10%. And so now I can draw an indifference curve, also called an ISO utility curve, through C star with a return of 9.2 and a risk of 9.94, such that we can demonstrate that we wouldn't have found this spot. I mean, here's the risk-free, here's asset 2, here's asset 1. How do I know that this is achievable? Well, I know this is achievable because I can draw my investment opportunity set, I can draw my cal through my investment opportunity set, and then I can find my spot on my capital allocation line. Now, very important, the only available allocation point on this ISO utility curve is portfolio C. The only spot on this ISO utility curve is portfolio C. All other available points are on the cal that are on this capital allocation line are below this ISO utility curve. And so nothing is as good as C. So for example, this spot right here, P star, for example, or just down here is achievable. But since this is equivalent on the ISO utility and better than everything on the cal, this must be the only good spot. So all other available points on the cal are below this ISO utility curve. So therefore, this is the best spot. And so we find W1 star to maximize P star, to find P star, which maximizes the slope, and then we find Y star to find C star to maximize utility. So again, P star maximizes risk-return trade-off or slope or the Sharpe ratio. C star maximizes utility. And we can only through this process can you start with asset 1, asset 2, and the risk-free and find C star. Okay, what about an investor with A equal to 11.90? So now, instead of having an investor with A equal to 4.25, we now have an investor with a higher risk aversion level. Now, this is very important. P star does not change. It's still the best slope regardless of the investor. It still gives us this best risk-return trade-off. So P star doesn't change. The 60-40 portfolio does not change. And so we still have an expected return of the optimal risky portfolio of 11 and the risk at 14.2 and a slope of 0.42. But now the difference is I'm going to have a different Y star. And so instead of investing 70% in the risky portfolio, I'm only going to invest 25% in the risky. And I'm going to end up with a optimal combined portfolio return of 6.5 and an optimal combined portfolio risk of 3.55. And my allocation weights, and remember before my allocation weights, here I was allocating 42, 28, and 30. 42, 28, and 30, which was 70 times 60, 70 times 40, and then 1 minus 70. Now my allocation is going to be, where am I here? 25 times 60 is 15, 25 times 40 is 10, and then 75% in the risk-free. And this is now going to be the utility achievable, and so my different risk-free rate is 575. And so now we can draw an indifference curve with this new C star. C star is different not because P star was different, but because it's a different investor facing that same investment universe. And so they will allocate differently than the investor with a risk aversion level of 4.25. This investor will allocate with a risk aversion level of 11.9, and therefore put less in the risky and more in the risk free. And so again, this investor is now optimized.